Here's the BYU High School Algebra 51 class unofficial lesson on 1.5. This is the distributive property, applying variable expressions. So the first thing we talk about is if two variable expressions equal the same thing, we can call them equivalent expressions. So basically what it's saying is equivalent expressions equal the same thing. That's like saying 2x plus 2 is the same thing as 2 plus 2x. Even though it's written differently, the commutative property can be applied here by just switching these sides for addition, right? So it's the same thing. Whatever you plug in for x, on the same side, you'll give you the same answer on each side. For example, if x is 1, 2 times 1 is 2, plus 2 is 4. Over here, 2 plus 2 times 1, 2 plus 2 is 4. So it's the same on each side, no matter what we plug in for x. Okay? So when they're equal on both sides, they're called equivalent expressions. The next section is showing you about proving that two expressions are equivalent. So you got to prove that what's on one side of the equal sign is the same on the other side of the equal sign. They give you one example of 3x plus 3 equals 3 times x plus 1, and they want you to show that they're equivalent, or that they equal the same thing. So here we start out with 3x plus 3. So we have 3 individual x's, right? 3 times x is the same thing as x plus x plus x. And then we have 3, so which is the same thing as 1 plus 1 plus 1. Okay? So here's 3x plus 3. Now, on the other side of our equation is 3 times x plus 1. So here they have written out x plus 1, and they've written it 3 times. X plus 1, x plus 1, and x plus 1. And if you look at the number of x squares in this equation, which is represented up here, there's 3 of them. If you look at the number of x's in this equation, which is represented down here, there's 3 x's, okay? There's also 3 individual 1's and 3 individual 1's. So it's showing that 3x plus 3 is the same thing as 3 times x plus 1. Here at the bottom it says that they're grouped differently, but they have the same number of x and 1 rectangles. Okay, so that's a visual representation to show that they are equal to the same thing. So you can show this instead of showing this like they did back here with counting up your x's and 1's. You could also use the distributive property and show it algebraically. Okay, so 5 times x plus 2 will go to 5x plus 10. And we're going to show you how to do that. So the distributive property is pretty easy. It's just saying whatever is there's one thing outside of a parenthesis group, you can break up the parenthesis by, if it's 5 times this whatever's in the parenthesis, right? Because if we write a number or letter outside a parenthesis, it just means times whatever inside. So we have 5 times x plus 2. Normally we'd have to do x plus 2 first, because order of operations says we do parentheses. What's in the parenthesis before we do times. But if we want to break it up and pull out that parenthesis, what we do is we can multiply 5 by each of the things inside of the parenthesis. So 5 times x is 5x, plus 5 times 2 is 10. Now I don't have a parenthesis anymore, and I've distributed the 5 into all variables inside, or all numbers or variables inside the parenthesis, okay? So here's the distributive property with letters, which looks weird, but it's pretty much the same thing. So it's saying a times b plus c, okay, equals ab plus ac. So I'll show you how that happens. Remember, whatever outside the parenthesis gets times into each factor that is inside the parenthesis, okay? So we have a times B plus A times C, which is the same thing as AB plus AC. So therefore, A times B plus C equals AB plus AB plus AC. Okay? So that's the distributive property in a nutshell. And now we're going to go through some examples. Okay, and I'm just applying this to that algebraic rule when we have a number, A, and it's times by whatever inside the parenthesis, which in this case is like B plus C, or 2 plus 2/3. We just times whatever's on the outside by what's on the inside for each of those factors. Okay? So A times B would be 45 times 2, which is written there. And A times C would be 45 times 2 over 3. Okay? And when we do the math for those, we get 90 plus 30. Okay? Because remember that if we divide the top and bottom of this by 3, 3 divided by 3 is 1, 45 divided by 3 is 15, and 15 times 2 is 30. Okay? So that's how the distributive property works. In example 2, we're taking the distributive property and we're going backwards. So kind of looking up here at the right side of the equation, you'll notice that A is common in both of these. And if we go backwards from this to this direction, we take what's common, which is A, and put it outside the parenthesis, and then times it by the individual factors that are not common, like B and C. Those are different from each other, right? But AB and AC both have A in them. Just like 45 times 2 and 45 times 2/3. It has 45 in them, so what's common goes on the outside. And then what's different goes on the inside of the parentheses. Okay? So for this one, we have 5 times x plus 8 times x equals 13x. So we are going to show this with the distributive property, because we could just add 5x plus 8x, and that would be 13x, but we want to show it with the distributive property. So what's common? Well, there's not a 5 in both of these, because this is a 5 and an 8. But there is an x in both these, so we can pull out the x just like we can pull out the a, right? So we pull out the x outside the parenthesis, and then we times it by whatever is different, the 5 and the 8. So it's 5 plus 8. Okay? So they show it down here too with the answers. That you, after that, you simplify what's inside the parenthesis. So 5 plus 8 is 13. So you have x times 13. And remember, with the commutative property, we can just switch places since it's times and not division. So 13 can go before x. Okay, so x times 13 equals 13x. All right, example 3. This is where the distributive property comes in handy, because we have to, with order of operations, we have to do what's inside the parentheses first, unless we use the distributive property and break up the parentheses. So here's what we're going to do. We're going to multiply 7 into n, 7 into positive r. Then we're going to multiply 13 into n and 13 into negative r. So we get 7 times n, 7n, 7 times r, 7r, plus 13 times n, 13n, and 13 times the negative r, which is negative 13r, because a positive times a negative is a negative. Okay? Then we add like terms to like terms. So we can add n's to n's and r's with r's. Okay? So 7n plus 13n is 20n, because 7 plus 13 is 20, and we keep the n. 7r minus 13r. So if we take the difference between 13 and 7, the difference is 6, and 13 is more negative, so it's going to be negative 6r. 20n minus 6r. Okay, so that's how we can use the distributive property. And remember, this like terms means that you can add something with the same variable expression. Variable expression means basically the number, the letter after the number has to be the same for us to add like terms. Okay. And a little bit of jargon for wording. The coefficient of 6x is 6. Okay. Coefficients are the numbers before the letters. Okay. Remember that coefficients are the numbers before the letters. So when we just have written x, remember that that 1 times x is the same thing as x, right? And that negative 1 times x is the same thing as negative x. So whenever we have x alone or a number alone like n, the coefficient is 1. It's either going to be positive 1 or negative 1, depending on if there's a negative or positive in front of that x, okay? Whereas the coefficient of 3x is 3, or the coefficient of negative 3x, the coefficient would be negative 3, okay? But with just x, it's going to be either positive or negative 1. Something important from this section is that an expression is simplified when there are no more like terms. In other words, when all the letters are different. So back here, this expression is not simplified because there are like terms. There's a 13n and a 7n. This equation is simplified because these are different. There are no like terms, okay? So in other words, when all the letters are different and there are no like terms, the expression is simplified. So make sure you always simplify an expression or equation, okay? Here's an example of simplifying an equation. We have like terms, right? Because y is the same and y is the same. So we have to simplify 5y minus 3y, which is 2y, and 19. Same thing with whole numbers. It's not simplified unless all the whole numbers are added together. Okay, and the last one here is kind of a weird thing, but it's saying there's a word expression, right? These sentences, which are hard to get at first. And you want to simplify it, justify each step. So for more than the sum of the difference. For more than the difference. So remember that when we have more than, it comes after whatever it follows the more than, right? And more than is an addition. So here's that for more than right there. For more than the difference of 7 and a number x. Remember, difference of means subtraction. Difference of 7 and a number x. So 7 minus x plus 4. And that's all inside of big brackets or parentheses. Increased by 5. So remember, increase is addition. 5 times the sum, so of 10x and 3y. Okay, so the sum is easy, right? 10x plus 3y, and 5 times that whole thing. Okay, so this is written in symbol form. Now we're going to use the distributive property for this part. Okay, we're going to go 5 times 10x, 5 times 3y. Okay, we're going to keep this left part the same. Then we have 50x plus 15y. That's the distributive property, right, that we just use up here. Okay. Next, we're going to use the commutative property. And we're going to switch these sides. We keep the sign with the x, so it's negative x plus 7. Okay. When you use the commutative property and change things around, you have to keep the signs. Okay. And then, since it's all addition here, we can use the associative property. Remember, if it's all addition, we can put the parentheses here, or we can put them here. Okay? And that's if they're all like terms, or they're all like doing the same thing, like an all addition. So they switched up the parentheses here with the associative property. Then we added like terms. So 7 plus 4 becomes 11. Okay. Now we use the commutative property. And we're going to switch the negative x and the 11. And then we're going to use the associative property to switch these parentheses to right here. And then we're going to combine like terms. So negative x plus 50x is basically like 50x minus x, right? So it's 49x. 11 plus 49x plus 15y. And that is simplified because all the like terms are combined and all the letters are different. Okay. And then here are the labs, and they have ways to work them through online once you complete them. So good luck.